Hello viewers, welcome to my YouTube channel. I am Dr. Leela bringing you series of lectures on the subject Signals and Systems and Python. In today's lecture, I am going to explain how to get a mathematical expression for a signal which is made up of only step signals and also verify by simulating it using Python. To explain this, I am taking an example of this signal, which is somewhat of a staircase type and having discontinuities and constant values. Okay, so such a signal which is having discontinuities and constant values, it can be represented mathematically by a combination of step signals. So let us see which are the discontinuities in this signal. So discontinuity 1 is at t is equal to -3, where the signal changes from 0 to 1. Before -3, the signal value is 0. And the second discontinuity is at t is equal to -2, where the signal value changes from +1 to +2. And at the third discontinuity, the signal value changes from 2 to 3. And similarly, at the fourth discontinuity, the signal value decreases from 3 to 1, and at the fifth discontinuity, it decreases from 1 to -1, and at the last discontinuity, it increases from -1 to 0. You observe here, between two discontinuities, the signal is maintaining a constant value. So between this discontinuities 1 and 2, the signal is having constant value of 1, and between discontinuities 2 and 3, the signal value is constant at 2, and between 3 and 4, it is constant at 3, between 4 and 5, it is constant at 1, and between 5 and 6, it is constant at -1. The signal exists from t is equal to -3 to +3. So let us see how to construct a mathematical expression for this using the step signal. So whenever we encounter a signal which is having only discontinuities and constant values, we don't require any other signals, only a combination of step signals with different amplitudes and shift with proper values of amplitudes and at proper instants of time. By either adding or subtracting or a combination of this will give us the signal that is having only discontinuities and constant values. So now let us see how we can start constructing a mathematical expression for this. For t beyond this -3, the signal value is 0. So it only starts at t is equal to -3. So from -3 to -2, we observe that it is having a value of 1. So we can represent this by means of a unit step signal which is shifted to t is equal to -3. So let us call the whole signal as x of t, and the first part of it is u of t plus 3. So u of t plus 3 represent a unit step signal which is shifted to t is equal to -3, and if this is only the signal, it continues at +1 throughout like this. But now at t is equal to -2, the signal magnitude changes from 1 to 2. So this change can be achieved by adding one more step signal of magnitude 1, which is shifted to t is equal to -2. So that is represented by u of t plus 2. The second step signal that is added with the first one to get the second discontinuity is u of t plus 2. So after t is equal to -2, the total magnitude that is present is 1 plus 1, that is 2. So at t is equal to -1, the magnitude changes from 2 to 3. So that means it requires one more step signal of unit magnitude added at t is equal to -1, that is u of t plus 1. So now we have three step signals with shifts from -3, -2 and -1 added together, and their total magnitude is 3. So this continues from -1 to +1. So at plus 1, the magnitude decreases from 3 to 1. That means there is a decrease of 2. That means we have to subtract a step signal of magnitude 2 and it is shifted at t is equal to 1. So that means the signal is minus 2 into u of t minus 1. So when the step signal is shifted to the right of the 0, it is t minus. So at t is equal to 1, we should add a signal which is minus 2 u of t minus 1. So at t is equal to 2, its magnitude further decreases from 1 to minus 1. So the change is minus 2. Okay. So we have to add one more step signal shifted to t is equal to 2 of value magnitude minus 2. So that is minus 2 into u of t minus 2. So now the sum of all these step signals is minus 1 after t is equal to 2. So that continues, but we want it to become 0 at t is equal to 3 to generate this signal. So add a signal here, step signal, which cancels this magnitude minus 1. That is, we must add a unit step signal at t is equal to 3. That is u of t minus 3. So sum of all these signals will result in the signal that is given here, which is in the form of steps of different sizes at different values of t. Now to simulate this using Python, let us move on to Jupyter Notebook. Here I have opened a Jupyter Notebook. Let me give the heading title for this as mathematical simulation of complex signals, or a simulation of signal with step signals, let us say. So make and rename this, and let us also write the expression for x of t here and make it as the heading of this cell. X of t is equal to u of t plus 3 plus u of t plus 2 plus u of t plus 1 minus 2 into u of t minus 1 minus 2 into u of t minus 2 plus u of t plus 3. Okay. U of t plus 3, t plus 2, t plus 1, u of t minus 1 minus 2 and plus 3. Okay. So this cell I will run it as a heading for this. So make it as heading here and run this cell. So this is the expression that we are going to simulate using Python. So, okay. So before we start writing the code for simulating each of these individual step signals, we have to import NumPy and also the matplotlib. So from NumPy, import, so let us say all the functions, and then import matplotlib dot pyplot as plt, and let me plot the graph in line so that percentage matplotlib inline. Okay. So run this cell. In the last class, we have seen how we can define the generation of a step signal as a function of time, amplitude and shift, and then repeatedly call this function to generate the required step signal with the required amplitude and shift. Okay, so let me do that. Define function underscore step, which is a function of t comma a comma shift. So here t time, a is the amplitude, shift is the shift, and this has to be terminated with a colon. And then we have to define an array u as equal to a zeros array of number of zeros is equal to capital N. We shall define what is capital N later. Then for I in range 0 to capital N, terminate this again, if t of I is greater than or equal to minus shift, this also has to be terminated. Then what should be done? Replace the 0 in this u of n for that particular value of I by the value a. Then return what? U. Return the function u. So here the first line is definition of the function, which is fn underscore step, and the arguments represent what are the variables. First one is the time, second one is the amplitude, and the third one is the shift. And each of these statements or functions defined, and then for all loop and the conditional statements all have to be terminated with a colon, otherwise you will get a error message. And next, let us generate a zeros array u is equal to zeros of n. So whatever may be the number of n that we choose in the next line, that many zeros, an array of that many zeros is generated by this statement u is equal to zeros of n. And next we shall check for each value of I between 0 to n whether it is below the shift value that is given to this function or above. If it is above, then replace the 0 in this array by the magnitude a. If it is below, leave it as it is. Okay. Then once all the values from 0 to n are over, then that constructs the required step signal of magnitude a and shift, which we will be giving in the next cell. Once that is over, that loop formation is over, that loop execution is over, it returns the array u, which is now modified. Started with zeros array, then now it is modified as per this requirement. Okay. So now you also observe here one while defining, we started with the column 1, and then it has to have a indent of one tab space. Next, for this for also, the next line has to have a one tab space, and the this will automatically generate it. The next line will be one tab space from if statement, column of if statement starting. Then return has to be one tab space compared to this definition, because that is the end of this function definition. So this has to be one tab space. Suppose if I make a mistake, you will see I'll purposely make this mistake. It will give a syntax error. So return is outside the function. So if I give a tab here, so it will be executed. So this new line number that has appeared here indicates that the execution of this cell is over. So now let us generate each of these signals and then add them appropriately. So first I'll give a name to this as u1. u1 is u of t plus 3, u2 is u of t plus 2, u3 is u of t plus 1, and u4 is minus 2 u of t minus 1, and u5 is minus 2 u of t minus 2, or like that. And before starting we have to define the x-axis as an array. T is equal to, let us make it as a linear space between, now our signal is from minus 3 to plus 3, so I can take from minus 5 to plus 5, and I can divide it into some 1000 points so that I get an accurate curve. I'll illustrate this. Suppose if we take less number of points, what happens? And n is nothing but the length of this array t, length of the array t, and initialize this a with magnitude 1, and also this shift is equal to 0. This is only initialization. And next let us define the first step function as u1, which is equal to, let us call the function fn underscore step with the required arguments. The first one is u of t plus 3. Its amplitude a is 1 and shift is minus 3 plus 3. So it is t comma 1 comma 3. Because it is t plus 3, I will give a value of t13. So next I'll ask it to plot dot plt dot plot t comma u1. Let us see whether it is correct. So now we have a step signal starting from t is equal to minus 3. Okay, this is. Now I want to plot all these all these 6 signals in independent frames of reference, axis of reference, and then add and get it final output also, except here also as in one more window independent axis of reference. So for that I'll make use of subplots. So how many plots I have to accommodate? 1, 2, 3, 4, 5, 6 and 7. So I'll divide it into 7 rows and 1 column and plot, go on plotting the individual plots. So I'll make a subplot statement, subplot 7 comma 1 comma, and I'll plot u1 in the first place, and let me also include grid. Okay, so this is our first one. Now you see it has become very small because it has to accommodate 7 subplots. So I will also define a figure size for this so that I can have a larger column length and shorter width. So for that the statement that defines that changes the figure size is plt dot rc params. So here after this shift I will define plt dot small rc capital P ARAMS RC params, and within square bracket and within colon within quotes figure dot fig size, and is equal to, now we give the size of the overall figure where we can accommodate all the 7 subplots. So I'll make it width is equal to 5 and height or the column height is equal to some 20. Okay. So now let me run this. Now you see in the first place I have plotted u of t plus 3. So now I will be repeatedly using these 4 lines. So I will copy this and make the changes for the next signal. So now the next signal I'll call it as u2, and this has to have a amplitude of 1. Let me take this. May I insert a cell below this and copy this and run it as a markdown cell. Okay, so that I can see the functions. So u2 is u of t plus 2. So it is amplitude is 1 and the shift is 2. And I'll plot it in the second place of the 7 subplots, and the plotting has to be u2. Okay. Now you see that the first signal which is shifted to t is equal to minus 3 and the second signal at t is equal to minus 2, both are of unit step signals, are being plotted. Now let me take this and copy this, paste it and generate the third signal u3. So what is u3? u3 is u of t plus 1. So it is magnitude 1 but the shift is 1. So draw it at the position 3 of u3. Okay. So let me run this so that I will get all the 3. Now 3 step signals are here. One at minus 3, another at t is equal to minus 2, third one is at t is equal to minus 1. All are of magnitude 1. Now the fourth one is minus 2 u of t minus 1. So that means, let me copy this. So u4, we call it as u4. So this amplitude is now minus 2 and shifted to minus 1, t minus 1. And let me make it as a fourth graph. This is a plot of u4. So the fourth graph, you will see here that this is at t is equal to 1, its magnitude from 0 to minus 2 it changes. So this is u of t minus 2 u of t minus 1. So next one is minus 2 u of t minus 2. So let me take this. So now it's minus 2 but at shifted to minus 2. Let me take it as the fifth graph, and this is the plot of u5, and let's also change the name to u5. So there is one more minus 2 u of t minus 2 which is plotted here as the fifth plot. Now sixth one is what is the sixth one? U of t, not t plus 3, it is t minus 3. So the last signal is u of t minus 3. So this is u6, which is having magnitude of 1 shifted to 3. So this is the sixth position in u6. So check the last one. Last one is a at t is equal to 3. It is a unit step signal. Now let me write the expression for x. X is equal to u1 plus u2 plus u3 plus u4 plus u5 plus u6. So all these added together, and now I must plot it in the last position of this subplot. So subplot 717, this is x t comma x. See here, the last graph is the one which is the required signal. It is 0 for t less than minus 3, and it starts at t is equal to minus 3 and continues 1 from minus 3 to minus 2. Then it changes to 2 at minus 2 and continues at minus 2 till minus 1, and at minus 1 it changes to plus 3, and from plus 3 it changes to plus 1 at t is equal to plus 1, and then it remains at 1 from t is equal to 1 to 2. Then it is changing to minus 1 at t is equal to 2, remains at minus 1 till t is equal to 3, then it becomes 0 at t is equal to 3. Okay, so this is the signal that we have already we have constructed using only step signals. So all these step signals along with the final signal has been plotted here. Now you see here the final signal is having 0 here, x-axis markings here and y-axis markings here. Let us beautify this by shifting this y-axis marking to the center of this plot, and also shifting this to this position. How to do it? Let me separately take this last plot and copy it to the next cell, and I'll make the plot size different here. So plt dot rc params figure dot fig size is equal to, I'll make it as some 8 comma 8. Okay, so this has to be within parenthesis 8 comma 8. Now let me run this. Because this subplot is here, that is why it is taking it as a small graph. So let me remove this subplot option. So now this is an 8 by 8 graph. So now instead of 8 by 8, I'll make it as 4 by 4 so that I can view it within the screen. Okay. Now to make such shapes, I have to use the plt.gca. So let me come to this point before grid. It has to be done, any changes has to be done before grid. So let me also define the x limit and y limit. Plt dot x limit from minus 5 to plus 5. I'll continue in the same line with a semicolon. It will consider it as a separate statement. Then plt dot y limit, I'll make it as that also from minus 5 to plus 5. Let us have a symmetric plot, or I can change it to minus 4 to plus 4 because we don't require up to 5. Minus 4 to plus 4. This will change the markings limits for x-axis and y-axis. Now y-axis, x-axis is from -5 to +5, y-axis is from -4 to +4. Still we have not shifted the axis. For that, plt dot gca, this will have the get control over the axis, parenthesis dot spines. So these lines are called spines in the grid, spines. Then within square bracket and within quote, I want to move the left spine to the center of the graph. So I'll make left. Then what I should do, dot set position, set underscore position, set position to where, within bracket, within parenthesis and within quotes, center, CENTER. Now let me run this. Now you observe that this line has been shifted to the center of the graph. And similarly, let me shift the bottom one also to the center. So instead of left, I'll make it as bottom and position it to the center. Now you see that both x and y axis have positioned to the center of the graph, but I want to change the color also. So let me copy this and make changes. Control C, Control V. So now instead of position, I'll change it to color. Color, what color? I'll make it red. Just see here the bottom spine which is shifted to the center, it is now in the color red. Now similarly I'll apply this to y axis also. Just copy the same thing and instead of bottom you make it left. It was the left spine which has been brought to the center, that is color. And let me remove these two lines so that the graph will look further in a symmetric way. Let me copy this and set color of the top and right as none, RIGHT, right as no color, and also the top one as no color, none. Now if I run this, you'll see here, this is the final plot that we wanted, and we can distinguish the x and y axis clearly. And but still it is not all that good because we are missing some tick marks here. It is jumping the alternate tick marks. I'm not getting 0, t is equal to 1 is not there, where I have to identify this. So for that, what should be done is, so we shall define x underscore position, x underscore position is equal to, make it as a list of range minus, see we want it to be from -5 to +5, and put a semicolon and continue in this line itself the next one, y underscore position is equal to, make it a list of range from -4 to +4, and in the next line put the x and y ticks, plt dot x ticks, x ticks, this is the syntax for x ticks, I plus 1 I plus 1 for I in x position. Okay, so that means observe what is the x position. It is the numbers ranging from minus 5 to 5. So start with the lowest value and put the marks from minus 5 plus 1, then minus 5, 6 plus 1, minus 7 plus 1, sorry, minus 5 plus 1 becomes minus 4. Put a mark on that. Then minus 4 plus 1, minus 3. So like that, every t value will have a tick marks and the value of that. And similarly, repeat this for y tick. Just make this y tick for I in y position. Okay, so let me run this now. Something wrong in the x position is equal to list range. Okay, now I have corrected the mistake in this x position, and also PLT, this was had become PLI. So now let me run this. So now you see that markings are for every one value of t and also the magnitude, and the graph is looking good, and we can change the size of this graph if you want. Just let me make it as 6 by 6. Say better appearance. So that completes today's lecture. Okay. In the next lecture, I'll explain, taking the same example, how to perform both shift and scaling, time scaling simultaneously. What is actually the procedure for performing the time scale and shift simultaneously? What we should do. Okay. So thank you for watching this. If you like this, press the like button, share it with your friends, subscribe to my channel. See you in my next lecture.